Hi, in the last session, we learned that how the flexible subcarrier spacing in 5G can lead to different slot lengths and how it can improve the network latency, which is crucial for time sensitive applications. We learned that how the higher subcarrier spacings reduce the slot durations. We also learned that why we actually needed flexible numerology in 5G to cater millimeter bands. Now, in this session, we will explore two additional features in 5G NR that further contribute to achieving lower latencies. In LTE, the transmission time interval or TTI is the duration of a transmission slot and it is fixed at 1 millisecond. As shown in picture, the shortest delay in the LTE between a downlink data transmission and the corresponding ACK or NAC notification in the uplink is 4 milliseconds. Although this 4 millisecond delay is acceptable for the mobile broadband applications, but it is too long for the ultra reliable low latency communication or URLLC use cases. In 5G NR, this delay can be significantly reduced, which make it more suitable for low latency applications. So 5G NR introduced the concept of self-contained slots. This self-contained slot allows more efficient data transmission, especially in TDD systems or time division duplex systems. This means that within a TDD band, the downlink data, guard period, and the corresponding ACK or NAC notification can all be accommodated within a 500 millisecond slot. Now, depending on the numerology, this entire process can be completed within a single slot. A part of the self-contained slot and flexible subcarrier spacing, 5G NR also introduced another concept of mini slot, which provides even more flexibility in the data transmission. A mini slot is just a shortened version of a regular slot. This is introduced to further reduce the latency by allowing quicker data transmissions. In NR, a mini slot can start at any symbol boundary. So there is no need to wait for the next slot boundary to schedule any data. That is why it reduces the delay. Additionally, the mini slot is not fixed in length. It can contain either 2 or 4 or 7 symbols. However, a standard slot is fixed at 14 symbols. So, mini slots can offer flexibility in slot duration based on the specific needs of the transmission. And this is especially beneficial for the low latency applications. This flexibility in the duration and start time allows low latency devices to transmit data without waiting for the next slot boundary or being constrained by a long slot. And this is effectively minimize the latency. Now let's talk about preemptive scheduling and understand how it works in practice. So in this scenario, the Mac scheduler initially allocates some resources to a mobile broadband UE, which you can see here with the gray color. But then we steal some resources from this pre-scheduled mobile broadband transmissions and reallocate that resource to transmit URLLC data, which is in red color. This happens to ensure that the URLLC low latency data gets the priority. This approach is known as preemptive scheduling, where your LLC data can override the pre-scheduled transmissions to meet its strict latency requirements. Now, if we are doing this, then we need to inform the UE as well that some of the scheduled slots are now used for other services. And for this purpose, a preemption indicator is sent, and UE get notified that some of its resources have been reallocated for URLLC data transmissions. These different level of flexibility are helping 5G NR to achieve lower latency, as your LLC data can be scheduled with a lot of flexibility in slot duration and slot time. Typically, the UE monitors the downlink control information channel or DCI channel to know when it needs to receive data. The UE monitors the channel at the beginning of each slot and then goes into the sleep mode for the rest of the slot duration to save the battery power. However, for the low latency devices that uses mini slots and the data can be scheduled at any time and at any slot, so we have a trade-off here because low latency devices has to constantly monitor the DCI channel and hence they cannot sleep between the slot boundaries and this increases the power consumption. Therefore, it's essential to understand the trade-off between achieving a low latency and maintaining the power efficiency. In summary, Mini slots and preemptive schedulings are the important design innovations in 5G NR to serve the ultra reliable and low latency use cases, and they significantly contribute in achieving this low latency requirements for the next generation applications. So that's it for today. In the next session, we will be talking about scheduling in 5G NR. So stay tuned for the updates. If you did not subscribe till now, then please do subscribe to learn and grow community for regular updates. If this video is informative, then please like this video, comment on video, and don't forget to share. Thank you for watching.